Hippocampus-dependent strengthening of targeted memories via reactivation during sleep in humans. This paper was written in 2013 by Luis Fuentemilla and others. My name is Max, and today we're going to talk about this paper. The research question: is the strengthening of individual memories via reactivation during sleep dependent on the structural integrity of the hippocampus in humans? To address this question, the researchers invited 3 groups. 2 of them were patients of TLE, temporal lobe epilepsy. They were subdivided into 2 groups. One, UHS, unilateral hippocampal sclerosis, which means in those patients, one part of the hippocampus was affected by sclerosis, left or right. And the other ones, BHS, bilateral hippocampal sclerosis, where both parts of the hippocampi were affected by sclerosis. And the third group, the control group, matched the patients in age and years of education. So on day 1, they did the learning phase. They had to learn there was a sound played, and then there was a word displayed on the monitor in one corner. And they had to guess the right word to the sound. Sound and words were not related. They had to acquire 50% in this test to further participate in the study. And during night, half of the sounds that cued learned words were played during slow wave sleep. And also slow wave density spindle sleep phases were measured during night. On the second day, they did the testing, so they evaluated what has happened overnight. So for the context, what we need to know is that the hippocampus plays an important role in spatial memory, and the anterior hippocampus plays a central role in associative relational memory processes, which is important because the TLE, so the UHS and the BHS patients, both have overlapping sclerosis in the anterior hippocampus, which is important for remembering words, for example. So the results of this paper: the hippocampus plays a crucial role in memory consolidation by reactivation of individual memories during sleep. As you can see in figure B, they can see both bars, red and green. They are both learned words, and the green ones are the ones that were cued, so played, the sound was played during night. The red ones, the sound was not played during night. So you can see there's a significant difference. So it actually worked, playing the sounds during night, but not for BHS patients. And the degree of memory consolidation is negatively correlated with the degree of impairment of the hippocampus. We can also see the hippocampal volume in figure C. So they can see it correlates with the results of in figure B with the recall. And BHS patients are remarkably bad at getting the position of the words right. Even though it didn't matter for the test, they didn't test on that one, but they were still asked to do that. And this may be something where you can estimate that there might be some other parts that were not working properly in the hippocampus. We see the slow wave density positively correlates with the spindle density and memory consolidation. So as you can see in figure D, this is the slow wave density. It correlates with the other 2 figures. What we imply from this paper is that the structural integrity of the hippocampus may reflect the degree of impairment of memory consolidation in TLE patients. So you can address this in a hospital, and they would know, so they're not that good at remembering stuff. Memory consolidation is highly sensitive to partial lesions in the hippocampus. As I said, the BHS patients are way worse at remembering the position, so there might be some other parts that might be affected. And the hippocampus may function as a gate for targeted memories to be reactivated. So you can actually, there may be all words saved in the hippocampus, and only the words, especially the words that you cued during night, may be strengthened more than others. So this is the implication of the entire paper. You can say that the hippocampus plays an important role in strengthening individual memories via reactivation during slow wave sleep. Thank you very much, and I'm happy to discuss this paper with you.